Well, we're pushing on here. Here we are. We're at evaluation. I hope there's space here. We're going to look at all these things for the arrangements. Fitness for purpose, efficient use of code and we've covered efficient use of code and constructs already. Robustness, readability, including internal commentary, meaningful identifiers, indentation and white space. Fitness for purpose. Does the program solve the original problem? Does the program meet the software specification that was created at the analysis stage? Any differences should be accounted for. Do the actual test results match the expected test data results? Efficient, we've looked at this, but we'll have a very quick look at it again. Is the program efficient? Does it have unnecessary lines of code? Remember, we used a loop to replace printing something 10 times by writing 10 times print your name. We could do it as a loop. That way, the loop itself, the for loop, the line that tells the program to repeat 10 times is translated once and the action is carried out 10 times instead of the 10 lines being translated by the processor. Do the loops repeat the correct number of times? Could the code have been written more efficiently? We've looked at efficiency, we've looked at conditional statements, we've looked at flowcharts, we've looked several ways to make code more efficient. If you cannot remember, look back over. How about robustness? What does a program do? If a program is robust, the question is, how does it cope with an error when it is running? Does it fail and stop? If it does, then it is not robust. Does it have input validation, which we've covered, built in, that allows data to be re-entered and the program to continue? So if your program's robust, it's got an error method. It's got a way of catching data that's entered that shouldn't be entered and allowing the program to continue until the correct data is entered. What about if the printer runs out of paper? That shouldn't stop the program. A robust program would tell you that there's no paper in the printer, but it would not stop the program. Readability. 4 factors make the program more readable. Internal commentary. Comment lines helps to explain what certain lines of code do. Comment lines do not affect the running of the program. And I've put a wee internal commentary there. This text has been enlarged and coloured to make it stand out. Meaningful identifiers, sensible variable names. This makes code much easier for someone else to understand and find errors. Did you have an identifier to make conversation earlier? Do you mean, what is my first name? Meaningful identifier. Indentation. Indenting loops and if statements helps you spot if and end if has been missed or if code is outside the loop when it should be inside the loop. Indentation. Everything inside a loop, inside a conditional statement, is indented. Makes it easier for another programmer to follow the code. And here we are. I've put this text in here deliberately. We've got spaces between each of them. That's because white space. Adding white blank lines can help to separate parts of the program, so it's easier to find the area of code you're looking for and easier to spot mistakes.